We know for some time that knowledge doesn't just reside in our heads, that actually knowledge is everywhere in our body. The knowing hand of the skilled musician or the skilled artist shows how one can pre-consciously make choices with the movement of the hand without having to rely on the brain. But now that idea of the location of thinking has been expanded again. There's a theory of the extended brain which argues that the brain is not only within the body, it also is in the space outside of the body. And in the immediate realm in which one can manipulate symbols and things, that becomes a locus of thought as much or more than what happens inside the brain. So what I would like to argue is that the tradition of the architect at the drawing table is the perfect paradigm of this notion of the extended brain, where drawing is not the mere record of architectural ideas already conceived, but it is actually the place and source of the generation of design. You see here two plans. They're about 4,000 years apart in age. The one on the left is a Babylonian plan of a courtyard house from about 2100 BCE. And you probably recognize the one on the right as the brick country house by Mies van der Rohe. And what's remarkable to me is that although there's been enormous change in human culture and tremendous change in architectural styles and architectural thinking, we're still able to read a plan that's over 4,000 years old. So while architecture has evolved enormously, our basic practices seem to have a remarkable continuity. And I'm curious about why that's the case. So I'm trying to understand what is significant about these modes of drawing and why they have evolved and stayed so relatively similar. I'd like to note that the plan on the left has cuneiform notes for the dimensions of the rooms, and I dare say there are very few of us in this room who can read the cuneiform, but I'm betting that almost everyone in the room can read the plan of the courtyard house. That suggests that architecture is not the same as the convention of language, that it has its own system of indexical relationships to building. So in addition to this question about the continuity of architectural practices, we're facing today a remarkable change in how architecture is approached. The top diagram describes the building information management system in programs like Revit, where a model is constructed in the computer that records all of the construction and other information about the building, and then the drawings are merely the output. So after some 4,000 years of drawing plans, we're now looking at the possibility of not needing plans to be the origin of building. Interestingly, the bottom diagram, which looks quite similar to the upper one, is from 1903, William Ware's American Vinola. And it shows what looks to be a very similar diagram, but really a very opposite notion about the generation of design. For him, it was the individual making of the drawing that allowed the projective imagination of the designer to conceive that three-dimensional building that's floating in between all the drawings. The exact opposite relation holds true for the BIM models. So we're now facing a very important moment in our history, and rather than simply discarding the knowledge that we've built up over the centuries, I think it behooves us to pay careful attention to the value of the traditions in the drawing so that we're able to translate them and bring them into the 21st century. To do this, I'll consider three kinds of drawings this evening. They're so mundane as to be often overlooked: the plan, the section, and the elevation. What you see here is a drawing from about 1490 from a manuscript of Vitruvius that was actually only discovered about 20 years ago. And it shows the Vitruvian names for the three drawing types as they were interpreted in the Renaissance: the ichnographia, the orthographia, and the scenographia. And in order to understand the contribution of these drawings, I want to look back to the beginnings of their development as the modern architectural practices of drawing developed in the Italian Renaissance. And during that time, the Vitruvian ideas of drawing were the basis for how they thought about and developed their own theories of design. So to begin with the plan, I want to recall where we are today. And I was taught, as probably most of you have been, that the plan is a horizontal section. And that is just taken as a fact, but it has a historical origin. The first person to introduce the idea of the plan as horizontal section was J.N.L. Durand at the end of the 18th century. His book, the Précis, was used to teach at the École Polytechnique in Paris, where he taught cadets the practice of architecture. The drawing on the right is from his book, and it shows his organization of the three drawings with dotted lines joining them together. His theory of architectural design was derived from descriptive geometry, which was developed by Gaspard Monge, who also taught at the École, and in fact was the person who hired Durand to teach in the program that was called Applied Geometry. Now you may know Monge developed descriptive geometry to describe three-dimensional objects in 2 dimensions. The diagram on the left is the first diagram in his treatise. And if you look at, there we go. If you look at this line, he says that you can project any three-dimensional object into 2 dimensions. So he takes projector lines like these and pulls them over to the vertical plane and then pulls them down to the horizontal plane. These 2 planes are joined with the ground line. And once he's made those projections, he folds the vertical plane down to the horizontal and thus gives you a 2-dimensional representation of any 3-dimensional object. Those of you who've been trained in orthographic drawings know that that's basically what architects have been doing for ages. What's different is it's become fully mathematized. And historians have said that he provided the theory for the practices that long preceded him. One of the differences, however, is that Durand was thinking with Monge that the space they were working in was abstract Cartesian space where there was no differentiation. So the X, Y, and Z axes can move in any direction. There's no relationship to the human body. So Monge actually says calling them vertical and horizontal planes was not to give them an orientation. He used that because that's what most of the practitioners would have been calling them beforehand. On the right, you see a student work from Monge's class where they used descriptive geometry to project shadows on a building form. What I want to claim is that prior to the rationalized theory of Cartesianism that was layered on top of architectural orthographic drawings, there was a prior theory which dealt with the embodied understanding of architectural drawing. And what I want to try to do this evening is to point out how that appears in each of these 3 drawing types. The other book that Durand published was called the parallel, and in the center is one of the plates, and he drew many buildings of the same building types on a sheet, each to scale. This is the temple at Luxor, and here you see Durand's Luxor plan enlarged, just for your convenience. In his preface to this book, Durand said that he corrected and improved all the buildings that he drew by locating them on a square grid so that all of the columns and walls were aligned with the grid. On the right, you see a modern plan of the Temple of Luxor, and you see how much liberty Durand took with the plan. So there were generations of architecture students who were understanding architecture through the power of this grid system that was restricting how they understood what was actually being built. Now, before the theory of the plan as a horizontal section was the idea of the plan as the ichnographia, which was Vitruvius's word. Ichnographia literally means footprint. And the footprint plan is powerfully different than the horizontal section plan. The horizontal section can occur anywhere in Cartesian space. The footprint expresses the weight of the body of the building that presses into the earth, leaving its trace or mark in the ground. So it is necessarily oriented to the earth and to the surface of the earth, creating a kind of a plane that's present on the earth. On the left is a 1556 explanation of ichnographia, and then the Italian word pianta on the left, which means both plan and plant. And on the right is an 18th century explanation of the ichnographia as footprint. And so if you reflect on it a little bit, while it may seem to have very little difference, there's really a profound difference in how you conceive of a plan as having the weight of the body pressing down into the earth. Now, one thing that I've discovered about trying to study architectural practices is that unlike theories, they can have extremely long continuities in time and can reappear even after the initial theories have been outmoded. So I wanted to show you as an example of that two plans from Frank Lloyd Wright's 1929 article on the plan, and he used the idea of the footprint plan. And so he contrasted the plan on the left as a brick pier plan, where the large squares of blackness expressed the concentration of weight in those points of the building, whereas on the right is a wood frame plan, where the walls are continuous but very light. So he's thinking about the weight of the building coming down into the earth and leaving a trace. He called this sort of plan a premonition of the building. Now, the ichnographia in historical times was often drawn directly on the site at full scale. Many foundation stories illuminate the practices because they draw on the ordinary practices, even though the story becomes extraordinary. This is an illustration from the 16th century of the foundation myth of the Fraumünster in Zurich. And you can see that in this case, angels are bringing the rope from the heaven, and they're setting it down on the earth to outline the plan of how the church should be built. And according to church documents, the rope was kept in the altar until the Reformation, when it was destroyed. So these kinds of stories illuminate the practice of the stretching of ropes on posts put into the ground to mark the site at full scale. Another sort of foundation story is called the Miracle of the Snow. This was from the founding of Santa Maria Maggiore in Rome. And in this case, the Pope had a dream one night, and according to the story, Mary came to him in the dream And although it was the middle of August and very hot in Rome, she said that there would be a snowfall the next day and that he should build a church for her where the snow falls. And the next morning, according to the story, he arose, and indeed he found snow on the site where the church would be built. And this painting by Masolino records that event where the Pope is using a hoe to trace the snow by carving it into the earth. So the message from the heavens is a transient indication, whereas the human action with the hoe becomes the beginning of actual construction. In all of these cases, there's an idea of the plan coming down from the heaven and then settling onto the earth. So clearly this is a sort of a footprint plan. And in addition to the ichnographia being full scale on site, it also became a drawing in scale on paper. And a student of Bramante, Cesare Cesariano, in 1521 wrote that an architect pacing out the building on the site in the snow is analogous to an architect walking the compass across the site of the drawing. And of course, the compass has its feet that leave its marks on the paper. So there's an idea that the practice of drawing at full scale in order to make construction becomes an index for how to draw in small scale on the paper to make the building. Filarete, a late 15th century architect who made the drawing at the top and was talking about the stretching of the ropes to lay out the site, emphasized that just as a site must be prepared for a building, so must the paper site be prepared for the drawing. And the Renaissance paper was not manufactured the way modern paper is. So it usually came fairly rough, and usually the drafter would take bone and run the bone over the surface of the paper to flatten it, and then take powdered bone, sometimes mixed with milk, and use that on top to size the paper so that it would better hold the ink and the chalk. So this practice of preparing the site of the paper really was quite similar to the practice of preparing the site of the building. And even into the 20th century, when drawing with linen or drawing with mylar, there was a similar use of pounce in order to prepare the paper for receiving the ink. So these kinds of practices, although the technologies may change, still have a long continuity. In this case, you can see how the measurement of the site with the ropes and the sticks literally became what we call the string of dimension lines in the modern architectural practice. So it's the ropes with the posts that become the string of dimension lines. Now, in the Renaissance, when the architects left the construction site, they moved into the scholar's library. This is John Milne, a Scottish architect, proudly sitting in his library at work with his compass. And the use of the table was almost consistently throughout architectural practice a horizontal table, probably coming from the library tables, but it also connects to the horizontality of the earth as a site. And of course, that sort of use of the table continues through the history of hand drafting into the 20th century. Of course, most of the time, boards have a slight slope to acknowledge the location of the drafter on one side, but they're essentially horizontal in their nature. So after arriving at the drawing table, the first act of the drafter is to fix the paper to the table or to the drawing board. This has been discussed since the Renaissance into 20th century handbooks, and they emphasize the importance of following the same procedure of fixing the 4 points. Many different materials have been used to fix the paper to the board. Wax used to be used, but for a very long time, drafting pins were utilized, and that's what you see in both of these images. The upper left is Bouwentwerfslehre from 1936 by Ernst Neufert, which was translated into Architect's Data, which you might know. So while we might think of this as a practical act, anthropologists have pointed out that the most practical acts are usually the ones that are most important to ritual activity. And what I wanted to suggest, going back to the time of the cuneiform plan you saw at the beginning, that this practice is also tied to ritual. And in the Babylonian era, and for a long time throughout the Middle East, ritual nails that were inscribed with magical incantations were driven into the four corners of the building to hold it in place. And every time there was a renovation of the building, they would re-secure those four nails. So this idea of fixing the building to the site was done ritualistically, and it's also then done on the drawing board. It's practical, but it's also a ritual. The lion is another kind of foundation peg from that era, which you can see in the British Museum. So once the paper is attached to the drawing board becomes the site as an analog. In the 20th century, drawing board surfaces were often covered with floor materials such as linoleum, so that the floor on which the drafter stands as the floor of the world is also the floor on which one draws. The paper, of course, is set square with the board for the sake of the T-square. And then the drawing board is set square with the building, which in turn is set square with the sun so that it controls the relationship of the sun's rays to illuminating the paper and orients the drafter to the board as well as to the larger cosmos. This again is from Ernst Neufert, 1936. A Renaissance architect insisted that drawing boards should be secured to the floor so they always remained in their proper location, so they wouldn't just get pushed out of alignment. Sorry. There we go. And then finally, returning to an image from Saul Steinberg, the drawing board becomes the site by extending itself out to become the floor of the world. I believe the reason that architects draw plans plopped in the middle of the sheet of paper and violate all of the rules of fine arts of composing the sheet with the frame of the paper is because for architects, the horizon of the world extends out from the site of the plan, so that it's important to be able to imagine the extension of the earth from the building site to understand all of the complex relationships with the larger site of the world. And so in this way, through all these many layers of orientation, the drawing board becomes the site for architectural design. I want to suggest that there's actually two levels of embodiment in architectural drawing. This image by Claude Bragdon from 1925. Claude Bragdon was a good friend of Louis Sullivan, and they were both American architects. He's illustrating at the front of his book himself at the drawing board, and Sinbad is his alter ego who's stepping out of the ink bottle to begin a voyage of drawing. So the double act of embodiment is the physical body of the drafter in relationship to the physical paper and the drawing instruments. And then the second level is the imaginative act of the drafter inhabiting the drawing itself, a sort of a mini-me, which moves about on the plan and imagines its occupation. We know as architects that when we look at a plan, we're not just thinking about it as a flat image. We're using it as a device to imagine all of the conditions of inhabitation. If we're drawing a plan in the hallway, we're thinking about walking down the hallway and what might be the view out the window at the end of that hallway. We add a great deal of information to our thinking in order to help our designs by directing our imagination with the drawing of the plan. And so we exist simultaneously as physical and imaginative bodies in the plans. This is an example of that. You probably know that we're instructed to locate plans with north up, and the north arrow tells us the orientation. That was true after the lodestone compass was invented in the middle of the Middle Ages. Prior to that time, east was up, which is why we call it orientation. And that was because east was thought of as being paradise. So east was at the top. Now, the sailors would use the windrows to organize where they would sail across the sea. And these drawings by Vincenzo Scamazzi from 1625 are the first case where the windrose is brought into architectural drawing as the north arrow, which you can see in the center circle. He has the magnetic arrow pointing to north, and the letters are the abbreviations of the winds in each of those directions. But the point I wanted to make about embodiment is that there is one factor that's more important than orienting north up. And that is something that's known but rarely discussed, that when architects draw plans, they draw the principal entrance closest to themselves. So the belly of the architect gives birth to the plan as we imaginatively move from our physical self through the front entry into the complex development of the plan. And you can see that's exactly what Scamazzi did here with the principal entrance close to his belly as he's drawing, being more important than the orientation of the drawing as an abstraction. So that physical relationship becomes an emotional relationship that's imaginative as well. To conclude with the plans, the image on the left is from Philibert Delorme from the middle of the 16th century, a French Renaissance architect. And the first marks that we make on the drawing, according to this tradition, is a vertical and a horizontal that intersect itself approximately at the center of the paper. Remember that early paper wasn't cleanly cut in 90 degrees, so you couldn't trust the edges, which were usually deckled. So the architect begins by establishing this primary right-angled relationship, and then all of the other measurements come from that. And that was exactly the same practice that they used pulling ropes on site. The drawing in the lower right is from the first Italian translation of Alberti, and that shows how you would drive a nail in the center and then pull the ropes on site in order to organize all the measurements for the building. So in this diagram of 3 crosses, the lowest diagram, Philibert Delorme explains, is both the drawing board of the architect and the pulling of the ropes on site. So it's a literal level of interpretation of what you actually do both as a designer and as a builder. The second level, where the cross is in the circle, is an analogical level of meaning, where it relates the microcosmos to the macrocosmos. Here, the earth is at the center of the diagram, and the heavens are circling around. Philibert quotes the philosopher Marsilio Ficino, that when the planets are aligned in a powerful way, like making this cross, that they can create miraculous events on the earth. In other words, you want to make sure you start construction when it's a very propitious time to build so that the building will be extremely successful. And so that's relating the building site to the entire order of the heavens. And then finally at the top is the mystical meaning. And Philibert talks about the relationship of the builder's cross to Christ on the cross. And I'm kind of illustrating that with the Vitruvian man from the first French translation of Vitruvius, which is very influenced by a Christian metaphor. So that as Christ is incarnated and becomes in the physical world, so the mystical becomes incarnated with the practice of drawing on the paper and building on the site. So that gives you a sense of some of the many ways in which plan becomes an embodied drawing as a footprint, expressing its weight, pushing down into the earth. The second drawing type, you recall, is the orthographia. And if you can see at the top of there, it's written orthographia, exterior and interior. The distinction between elevation and section was rarely made in the Renaissance. They would confuse the names and confuse the drawings back and forth. I was very curious about why that's so, and it seems to be that anything that showed the vertical height of the building was considered what the English called an upright drawing. So the vertical dimension of the building was explained by the orthographia, just as the length and width were explained by the plan. So with those two drawings, you explain all the primary dimensions of the building. And whether it's interior or exterior isn't quite as significant. If you look at these two plates from Palladio's 4 books on architecture, you can see that although some historians have suggested that architects drew plan and elevation together because they were lazy and wanted to save paper, it actually is because they wanted to understand the relationship between the different depths of the building to each other. And that's what Raphael wrote in 1515. So here, if you read the building through the drawing, roughly from left to right, you see 4 different levels of elevation and section explaining the complete relationship of the building as an upright throughout the totality of the structure. Now, I've referred to Duran's use of the Cartesian X, Y, and Z axis in abstract space. Prior to that time, there was an Aristotelian notion of space, which was based on the human body. And so the 3 dimensions were front, back, left, right, and up, down. And that was the way that space was conceived of, so that when the body was in an architectural space, the space was already being described through its inhabitation. The orthographia is comes from the Greek word orthos, which means upright or vertical. And already in Plato, the use of the word orthos mixes the physical description of upright posture with the ethical description of moral correctitude. So the orthographia has always been interrelated between the value of being physically vertical and the value of being righteous and true. In the story of the origin of building that Vitruvius tells, and is illustrated by these 2 images from the Renaissance, Vitruvius explains that human beings were beasts who walked with all 4s on the ground. And it was only after fire came and they started to organize themselves and then to build huts and communicate so that they could erect upright posts to construct their enclosures, that the human beings developed the upright posture so that they became related to the posts that they were building with. And Vitruvius follows Aristotle in explaining that in the upright posture, the human being's most important physical element, the head, is a sphere that's closest to the spheres in the heaven. So there's an idea of the interrelationship between the orientation of the body and the orientation in larger environment. These same ideas were brought into the 20th century. On the left is Humbert de Superville, and on the right you may recognize the poem of the right angle by Corbusier, both of whom emphasized that in standing upright, we are connecting an axis from the center of the earth to the highest point in the heavens. And this idea explains the orientation of human beings in the earth, and of course it also implies the verticality of the plumb line, which directs you to the center of the earth. So the orthos is the upright or the vertical, and if we look at that in terms of the drawing board, we can see how when architects left the construction site and moved to the library, that they brought the constructor's tools with them. So for example, here you see the square and the compass and many other tools in this late medieval image. And then in the Renaissance, you see those same things appearing on the drawing table, although usually at a smaller scale. This is the image of the architect from the Campanile in Florence from perhaps the middle of the 14th century. And the image has been repeated many times, but curiously, no one has bothered to look at what's on the top of the table. So we did, and we discovered that not only is there a compass, but there's also a set square there. So they were describing the ability of the architect to make the right angle as well as the circle. So the Mason's set square was taken from the construction site and brought to the drawing board at least by the 14th century, if not well before. Now in the United States, we call these things triangles on the drafting board. I don't know what you call them here in Australia. Do you call them triangles? Set square? I know that in England, they're still called squares. So that idea of the set square continues, at least in some places, more strictly. The T-square was the carpenter's square, brought from where they would use it to mark the wood, to cut the wood straight. Now it becomes the horizontal line. This is a drawing from 1505 as an early illustration of perspective. And you can see that the paper is attached to the drawing board. The circles are not tape dots, they're wax. And a lot of historians have argued that the drawing board system did not appear until perspective. But I believe it's actually much older than that. And what happened was no one bothered to talk about it because it was such an everyday thing. But once perspective became so interesting, then people started representing the drawing board tools in order to talk about the conundrum that is perspective. So in this example, you see the perspective drawing quite accurately to a vanishing point, but then look at the perspective of the T-square in the drawing board. It's a completely different system. It's almost more axonometric in nature. So I would suggest that the inability of the drafter to see them both being drawn in the same perspective technique suggests that the T-square and drawing board as a practice are prior to the practice of drawing perspective. And of course, these tools, although they've changed in their material and their precision, are basically the same thing that architects used through the 20th century. Now, when architects drew the orthographia, the upright drawing, there were very specific instructions in many of the treatises that you begin with a horizontal line, which is the earth. Remember that the plan was also called a plant, even in English. And you would plant the plan into the horizontal line, and then you would raise the verticals to grow the building. And Daniel Barbaro, in the middle of the 16th century, compared this process of growing the elevation to a plant growing up from a seed in the ground into the sky. So this process of growing meant that they always drew from the ground up, so that they were always thinking about the process of constructing the vertical by building up. It never was from the sky down. And just as a plant is very different in its roots and its stem and its flowers, so is the possibility of growing an elevation extremely differentiated at different points. It's very different than the Cartesian idea of the extruded elevation, which merely becomes the same thing through its extrusion. For example, Dürer wrote, "The plan should be laid into the ground and then drawn up." So these processes continue in the 20th century. Of course, if there's a sheet of paper laying somewhere, it has no orientation. But once it's fixed to a drawing board and the drafter's body is oriented to the drawing board, the paper immediately takes on what we always call a header and a footer. And so the horizontal line drawn by the T-square becomes the realm of the earth, drawing the pencil from left to right across the body. And then the vertical line is drawn with the square or triangle set on the T-square, and so it's the vertical that's established in relation to the horizontal. So the plan horizontal is always fundamental, and then the vertical is drawn up out of the horizontal. And the 20th century textbooks insisted that you had to draw the vertical line from the bottom up. So just like the Renaissance plant growing up into the sky from the ground, we still have that practice of drawing the line vertically, coming up from below. Even though, as the twist body indicates, it's a rather awkward procedure to do that. They still expect it to be drawn that way. Now, the orthographic view after Durand was theorized as a subset of perspective, inverting much of what I've just been talking about. So the idea was, whenever you have a perspective, you have where the person is standing and then the rays coming out diagonally from there. In parallel projection, of course, the rays are all parallel. So the way they defined it is that in orthographic drawing, you're standing at infinity to be able to see everything straight on. Because of the oddness of this explanation, standing at infinity, it suggested to me that there was an embodied theory of architecture that preceded the rational theory, and that it got layered and mixed into it. So I looked back into theories of vision, and Alhazen was one of the great Arab philosophers, and his work was translated and available in the West. And he identified two different kinds of vision. He said one is superficial vision, where you see everything at a glance, but you don't see anything in detail. And that, of course, is the perspective view, where you see everything at once. The other kind of vision he called visual scrutiny. And he said that's when you look slowly across the surface of a thing, where you always maintain the eye at a right angle to the surface, so that you're able to see everything as it is in reality, in orthographic relation to it, so all the objects are the same. So this roving eye, fixed at a right angle to the object, is the exact form of vision, and that is what Renaissance architects were describing when they were talking about the making of the orthographic drawing. So they were actually looking at the building And they describe in some detail how you should look vertically from the ground up between each column and then go to the next bay and the next bay. So they're using the idea of visual scrutiny, which means you're close enough in physical reality to see the detail, and you still have the true sense of the proportion of the thing because you have that right angle relationship to it. This contrasts with the modern description, which says you stand at the building and you walk backwards to infinity, and then you have the perfect orthographic view, which is really an absurd way of thinking about an embodied understanding of the orthographic drawing. So the orthographic view becomes a face-to-face relationship between the architect and the building, the facade of the building and the face of the architect. And I especially like the way Tom Main drew himself in relation to the facade of one of his buildings to describe that relationship. So you've made it through both plan and upright. The third kind of drawing is the scenographia, and unfortunately this is the trickiest one. Because of the word, theorists have argued over whether it means a perspective drawing or a section drawing. And some people said it actually meant both. Now, the order in which the drawings are recited is plan, section, elevation, right? That's what we always say. It's what Durand called the natural order of building. He said you begin with the horizontal section, then you make the vertical section, which describes the construction of the building, and the elevation is merely the result of the first two. So the elevation is the extrusion of the section and the plan, a very Cartesian notion of thinking about architectural space. So he gave us that modern order. Prior to Durand, the order followed Vitruvius. As you see in these two 18th century texts, it's always plan, elevation, section. And it was said that way because in the Renaissance, they thought that was the description of the order of building. The plan on the earth pressing into the ground, giving you the length and the width. The upright drawing is the orthographia, giving you the height, and then the section. So the question is, what is the third drawing doing once you've already explained all three dimensions with the first two drawings? The modern explanation is that each drawing covers one of the three axes of three-dimensional space. What is this theory in the embodied thinking of drawing for this third drawing? And how could it be both section and perspective? So I want to look a little bit at the generation of section in order to be able to answer that question. One of the key elements in the creation of section drawings, which came a little later than the first two, is the ruin. This is a drawing from Sebastiano Serlio from the middle of the 16th century. He's drawing ruins in Rome that actually are ruined like that. You can still see that building. He called it the Temple of Peace, but it was a misnomer. But you can see how you're able to see into the interior because the ruin of the rest of the building had fallen away. But not only did he use that technique for talking about actual ruins, he used that same graphical technique to represent the design of future buildings. This is Bramante's dome for St. Peter's, which hadn't been built, but he's drawing it as if it's ruined along the edge. And he apologizes in the text, saying that he did that on purpose, that it wasn't an accidental ruin. So we see that the idea of the ruin becomes the break line in modern architecture. The way we represent where you stop a drawing is the ruin, which goes directly back to Renaissance practices. Another very important element of the embodied section is the wound. And I won't go into it in great detail, But in most of human history, it was thought to be abhorrent to look into the human body, that it's too sacred and too important to tear it open, even after someone is deceased. So the only way that physicians were able to develop knowledge about the interior of the body was by peering in through a wound. This was the way that Galen learned about the anatomy of human beings, because he was a physician who worked at the Colosseum and took care of a lot of the gladiators that suffered wounds there. But probably the most important idea about wound in the Renaissance were the 5 wounds that Christ suffered when he was nailed to the cross, the most important one being the wound in the side. And on the right is a 15th century representation of the side wound that becomes the representation of Christ as a body. The wound was theorized as a door that allows people to enter into the Christian life, and it was compared to the door of a church or the door of Noah's Ark. So this idea of the wound can be seen in San Gallo's drawing of the temple, particularly the one on the left. These 2 temples were in ruins in Rome, and he had to reconstruct the design of the temple, and then he had to ruin it in order to create that ruin. And if you look at the shape of the ruin on the left, it's very much like the vesica Pisces of the wound of Christ. So here we are standing outside the building, looking at the exterior, and then looking through the exterior into the interior, but it's only a partial view. So we all know that there's more information there than we can see. In modern times, this becomes the cutaway section, which is often used to reveal some secret mechanism inside of an object. But it's also used in architecture to reveal the building while the interior still remains something that's secretive, that isn't fully revealed. Later, in the 15th century, the dissection of human corpses became legalized, and they started to have public dissections in leading cities. Today, we compete for major sports teams and build arenas for them. Back in the Renaissance, they were competing to build dissection theaters where the public would be able to go to see a body dissected. Coming out of this new empiricism of human anatomy is Vesalius's book. A few of the illustrations of what are called the muscle men are here. He actually has quite a few more. But again, I wanted to note that there are many different sorts of sectioning. And here you can see that there's flaying of the muscles. So they are slowly cut away. So you can see each of one of them in turn. And that's quite similar to Rusconi's drawing of the way that you would put plaster onto a hung ceiling. So you see the flayed layers of the construction of the building. Or Leonardo da Vinci, who famously dissected 2 human bodies, made these incredible drawings of the human anatomy. And at the same time, he was making architectural drawings. And it's likely that these are some of the early sections that are made. Now, most of the time, an anatomical drawing is not a cut all the way through like an architectural section. But when you look at the human skull, because that has to be cut away, it actually becomes very much like an architectural section. And so he's comparing it to the idea of the dome of the church. And he, on the same sheets of paper, he moves between drawing human body elements and drawing architectural elements. But we don't get the name section for the drawing type until later. It is still a confused name with the orthographia and the elevation. In the 17th century, there are 2 great anatomist architects at work, one in France and one in England, and they give us the word section for the drawing. What you see here is a dissection taking place in Paris with Claude Perrault, who also designed the east front of the Louvre, cutting open a creature. And when he was an elderly physician architect, he cut himself while he was dissecting a camel and passed away from the infection from that cut. On the left is his drawing of the Scenographia, and on the right is the drawing of a chameleon. On the left is his Vitruvius, and the right is his natural history. And you can see how his thinking moved between both of these in a very direct way. I really enjoy the way the perspective aspect of the Scenographia is shown in place as if it's a view into the city, whereas the section cut is on a sheet of paper that's visually hung onto that prior piece. And of course, in comparison with the chameleon, that's where you see the skeleton and the organs from the interior. So a truly anatomical section is not one that's just cut flat through. It's ones that are taking parts out of the body. That's what anatomy means. And in Perrault's Vitruvius, on the very first page, the headpiece is on the upper left here, where you see Vitruvius presenting his design to Augustus. And the drawing is the same section that Perrault uses later in his book, which I've enlarged for you. And you can see that rather than making a section as a flat cut, the wood is broken away and splintered. The walls, the blocks of stone, are staggered because he's pulled them apart. And my favorite is the column that's floating in the air, as if it is an organ that's being taken out of the body during the anatomy. So he's understanding the construction of the building through its organs, its primary parts, that become present in this sort of anatomical section. And if we look at the same time in England, we meet Sir Christopher Wren, who is known as a great mathematician architect, but he was also involved in human dissection. He worked with a scientist by the name of Willis, and they dissected the human brain. And because of Wren's keen observation and incredible drawing, which you see reproduced there, they actually discovered new parts of the brain that no one had seen before, and they're named after them. At the same time he was doing that dissection in Oxford, he was designing the Oxford Theatre, which was built, and I suspect that there is a relationship between the two, but I'll leave that up to you to decide. I do want to point out, though, that the theater was also intended as a location for dissections to train the students at Oxford. And then I actually found in Wren's drawings from his office that some of the sections were labeled dissection, as you see in this drawing on the right. So he's actually connecting the dissection of the building with the dissection of the human anatomy. So that gives us then the section drawing. But we still haven't figured out the answer as to why there's a third drawing when two are sufficient. So I want to conclude by trying to offer an answer to that question. This drawing is from Villard Dahana, and a lot of people have called it a section. It's through a part of a cathedral, and if you look at the bottom part, there are these wavy lines, which are thought to represent the stone of a wall. This would be the section through a roof, although it's not indicated as a section. The most noticeable element in the drawings are these really dark areas inside the primary vertical pinnacles to resist the outward thrust of the walls. Those are actually open air. They're made so that workmen can pass through them. So they should be the same as the air next to it, but they're made completely dark. And what I think is happening here, although I can't really prove it, is that it's the sense you get when you walk into a very tight space inside stone masonry walls. You feel as if you're inside the wall itself. So the darkness of it and its shadow is describing the psychological experience of feeling enclosed in the wall, even though you're in a space that provides for your access to the building. These images are from Francesco di Giorgio, whose architectural treatise was quite early in the 15th century. And he said that there are bodies in columns. And he was very interested in the problem of architectural drawing. And he said that architectural drawings have to show the visible, the invisible, and the mystical. It was Leonardo who studied these drawings in great detail and annotated one of the copies of Di Giorgio's treatise. And Di Giorgio influenced many of the other architects that I've shown you who've worked on the beginnings of section drawing. And in this case, the way he's representing it is that the solidity of the column becomes transparent, so the body within is visible at the same time you're reading the solidity of the column. So it's as if the column were glass or something like that. But he's trying to represent the inside and the outside simultaneously. And so in this case, the body is not in a tight space between the walls, it's actually within the solid material itself. Going back to the foundation stories, there is an incredible tradition of foundation stories that is spread throughout most of Southern and Eastern Europe, where the master mason wasn't able to keep the wall from collapsing. And so the witch told him that he had to inter his wife into the wall to give the wall life so it could stand up. It's a really kind of a horrific story. And sadly, she had twins shortly before then. So as he was walling her into the wall, she begged him to leave room for her breast so that she could continue to feed her babies even after she was inside the wall. So while this sounds like a kind of a horrible story, it actually has many significant symbols about the relationship between human life and the life of a building. The soul that lets it grow up out of the ground, the vegetative soul, like a plant. And there are actually some buildings in northern Italy where they have built that as a representation of that story, as if there is a body within the wall. This is called immuring. Mur is Italian for wall. And now it means that the body is not distinguished from the stone, but the body becomes the wall itself. The body becomes stone. And this becomes a kind of an uncanny description about the relationship between the body and building. But I believe that this is at the very center of how we understand embodiment in architecture, because it's in these cases that we understand the solidity of the wall not as an other, but we understand it as ourselves in relationship to the building. Jacques Lacan coined the word extimate, which is a combination of exterior and intimate, and he said that our ego is actually outside of ourselves. It isn't inside. And so that how we relate to the environment determines our well-being. And at the core of the embodied building is that relationship where we come to know ourselves through the solidity of the other. And through that dichotomy, we're able to understand our relationship to the other. So to conclude, we've looked at plan, section, and elevation. And the section becomes this uncanny condition of depth. And the reason that I think it's both section and perspective is because it describes depth in a very unique way, not depth as another measurement, the way Descartes described depth as length turned sideways, but depth as being that primordial condition of our relationship to the world as we look into space. When St. Paul was talking to the Ephesians, that was recorded in the Bible, referring to the temple there, the pagan temple, he talked about it as having length, width, height, and depth. So he gave it a fourth dimension of depth, which in Latin is our word profound, as a condition of existence of the building. And I believe this section becomes that notion of profound depth, the immeasurable element that lets us understand our relationship to the world. So when Bertotti Scamozzi was commissioned to draw all of Palladio's buildings, he drew an incredible number of drawings, and all the sections have 45-degree angle section lining in them, just like we're told to draw today, or of course now it's a select fill on the computer. And as you know, section line drawing, if you've ever done it by hand, is not easy, and it's very precise. So it requires a real rigor. So at the same time that it's incredibly boring, it also requires a lot of attention. And I suspect that section lining is the ritual immurement of the drafter into the wall, going through this tedious process. The other way that Bertotti Scamozzi showed section cuts, you can see in the columns. Here they're broken apart, and as they have that ruin line like Serlio had, they start to have little bits of greenery growing in them, vines and plants and things, as if it were a ruin. And in a few places in the book, the section cut actually comes alive into an environment. So here the drafter is living in the solidity of the stone column, but it becomes another world, a world of the imagination. And so I'd like to suggest that if we look at these conditions of embodied drawing for plan, section, and elevation in architecture, it isn't that I'm arguing we have to give up on computers, but I think we want to make sure that the computer is a tool that works for the architect, that helps us to imagine and design. And so the interface and the program needs to be made in a way where it takes the strengths of the tradition of hand drawing rather than just ignores it. How is it that the computer operator is going to be able to discover the same sort of joy in the execution of drawing that Bertotti Scamozzi did? If you want to know the answer to this question, come tomorrow night, and Jason Crow will be talking about some of these issues, but from a totally different perspective, from the point of view of the question about the computer and how it's used today. So I'm looking back in time, he's looking forward. Thank you very much for your attention this evening.